Welcome back to a new video. Thank you first and foremost if you watched the last video where I went over high availability and disaster recovery concepts. This one is actually going to be even more fun. We're going to be configuring switching features, right? Yeah, configuring VLANs, access ports, and trunk ports. Now we're going to go over the virtual local area network, how to segment our network into multiple segments, right? Which are essentially VLANs. So I'm also going to go into the difference between access and trunk port and how to configure them on L2 and L3 switches. So I'm going to create a VLAN, and when dividing a network into different segments known as VLANs, which is mandatory, right? But it must be planned when designing a network. Now, when creating multiple of them in your network, what I'm doing is I'm logically dividing my network into multiple segments, where VLAN is a group of devices with similar needs for network resources. They're also usually created for specific departments, right? That have specific requirements like IT, finance, and management. They need resources to access the main network, but obviously for different needs. Now, I'm just going to get into how to logically divide a network and things to consider while designing virtual local area networks. And I'll be using a Cisco switch to configure on a switch, right? So just going to get to this here. We do not want that. So now I need to enter exec mode, which is going to be this one here, right? And as you can see, enable, and then it allows to switch with the hashtag, right? So now I'm going to tell it to configure the terminal. And I've done this I didn't go as in depth into why these commands matter, but I have done this on a prior video in my cybersecurity series, right? So now that I've done that, now when I configure the VLAN, I must define a few parameters: the VLAN ID, which is mandatory, and the VLAN name, which is usually an optional parameter. Now I'm going to create 4 different VLANs for users, finance, and servers, and I'm going to just come up with I haven't come up with the 4th one yet, but let's see, VLAN 10. Let's see, actually, should give me, let's see here, name going to be users, right? And then VLAN, actually, I'll just start with users. I'll do one at a time. So I'll actually just exit out of here. And then we want to do VLAN 20. It's not how I want it. And then I'm going to do name finance. Then we're going to exit out of here. Then we're going to do VLAN 30. Name servers. I'm going to exit out of here. Then VLAN 40. Name under. All right, perfect. So actually we can get out of here too. And we're actually going to exit. We're going to exit to show the VLAN brief. Okay, users, finance, servers, Dunder, Mifflin, all 4 that I've created are all active. Perfect. So the switch has, if I didn't create a name for either of these, it would have assigned a default name to VLAN 40. And all ports are by default placed in VLAN 1, the default VLAN if we don't do anything else. Now we're going to take a look at our access points, which is for our data virtual local area network. And the access ports is where end hosts such as like computers, printers, IP phones, and similar devices are connected. What I'm about to do is configure a port as an access port, and I'm going to configure the port where another Server, mainly this one, is connected to be a member of VLAN 10, and I'll test the configuration by creating a switch virtual interface on the switch, and then I'll ping the device. So let's actually go back into configuring our terminal. Going to do interface. Perfect. And then let's take a look again. Yeah. Okay, perfect. So we're still looking good so far, right? As far as our output, we could also see that the fast Ethernet 0/1 is now placed in VLAN 10, right? So we see that. Now to test this, I'm going to create a layer 3 interface on the switch. Now in the lab topology, I can see that this device connected to port FAO1 has the IP address ending in 10, and I'm going to configure the interface and assign it to another one. So let's actually go back in to the terminal, right? And we're going to do base VLAN 10. I'm going to do okay. All right. You're going to let me type now. All right. Perfect. Perfect, perfect, perfect. So now I'm going to issue a ping to this device using the source interface VLAN 10. So let's ping this guy. Perfect, 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 perfect. So the ping was successful, which means our port is configured correctly. So now let's take a look at a trunk port. A trunk link, usually a link between two switches, and by default on Cisco switches, the trunk link carries traffic from all of the virtual local area networks. Now, Cisco commands can be used to limit the number of VLANs that could be transmitted over the trunk link. And a trunk could carry different VLANs because the frame passing through carries a VLAN tag in its header. Some switches from other vendors don't have a trunk port. Instead, VLAN is allowed to be transmitted over a particular port as tagged or untagged. And if we're adding a VLAN to a trunk port, I will use the tagged option. If I'm adding a VLAN to an access port, I will use the untagged option. So let's actually swivel over to this one here. No. All right, perfect. So let's go ahead and sec mode. All right, there we go. And now I'm going to configure the VLANs 10, 20, 30, and 40. I'm going to do that with a few commands. Naturally, going back inside the terminal. All right, and VLAN 10. All right. Okay. Exit out of there. Then almost forgot about 40. Okay, well, let's get out of here. Perfect. So now I'm going to add a host name to this device that we're on, and the access one switch is to distinguish between them. So take a look at this name. I'm going to exit out, right? And then I'm going to swivel back over here. Right, and then host name. Perfect. All right. So now I'm going to configure a trunk port to create a trunk link between the switches. Now, let's see. Let me actually get back into the terminal to do that. All right. There we go. All right, perfect. So let's actually swivel back over to core two, and let's pretty much do the same thing. Okay. No, no. Okay. That's fine. Now, when I try to configure a trunk port on this switch, I get the command rejected error message, blah, 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 blah. This and that, right? So core two is a multi-layer switch. So I must first specify the encapsulation to either be .1Q or ISL. And these are two frame tagging protocols that differ in how they encapsulate frames and insert tags. And ISL is Cisco's proprietary protocol, while .1Q is actually an IEEE standard. And what I'm going to use is the .1Q. So um, let's do this here. Okay. Let's see. There we go. Now, yeah, now we get it. All right, perfect. So let's circle back over here. All right, and let's take a look at something. Okay, perfect. That's what I wanted to see. Now from the output, it could be seen that FAO 23 interface as a trunk point with a trunking status. Now, if we take a look at the VLANs 1, 10, 20, 30, right, and 40 are allowed VLANs over this trunk, and VLAN 1 is a native VLAN. So VLAN 1 is the default that I mentioned earlier that can't be deleted and is native by default on trunk links. This means that the traffic that belongs to VLAN 1 would not be tagged when traversing this link. I'm going to swivel back over to here. Actually going to take a look at the same thing. Actually, that's better. Okay. Now we can see, all right, all of these on here, right? Now, again, we've seen that the FA1 022 interface at the trunking status of the native is VLAN 1. Now, for proper operation of a trunk link, native VLANs must have the same VLAN ID on both ports typically. All right, so now to check the functionality of the trunking that was configured, I'm going to create an SVI interface on this switch. So let's actually go back into the terminal. Right. Yep, I knew that was coming. All right, let's see what happened here. All right, so we got that situation figured out. So I did the IP address, and now we can actually end it in this here. And now I'm going to issue a ping from this switch to the other, to this one here. So I'm actually going to do a ping from here. All right. Perfect. And that's what I want. So the ping is working, which means that the trunk port is successfully configured. Now we can take a look at the access port, which is a voice vocal virtual local area network. Now most IP phones today have an integrated switch module that can be used to connect your computer to the network. Usually IP phones are placed on the same desk as the computer, especially if you've been in a call center with the phone connected to a wall jack. Well, I hope they don't have wall jacks the same anymore. And the computer connected to the IP phone. Now, a voice VLAN is used to configure the port where the IP phone and the computer are connected. But enough about that. I'm going to get into issuing a few commands to view the Cisco devices that are connected to this switch. So first, we're going to show the CDP neighbors. All right. There's all of these guys here, which is fine. Looks pretty okay. Now, if I notice from the output, we do have an IP phone connected on a port fast Ethernet that we can actually see here, right here. Now we can configure that to be a member of the voice VLAN 40 and a data VLAN 10 by issuing a few commands. Now, because of the lab environment that I'm in, I don't have a PC connected to this port, hence the commands that can be issued are shown, but not necessarily can be tested to verify the configuration change itself. So let's actually definitely get that one. Hello. All right. We're going to take a look at face fast Ethernet. Oh, let's do switch port mode access. And then we're going to do switch port voice. Left 40. We're going to do switch port access and 10. And that's the end. Perfect. All right. So now what I can do is verify the status of the configured interface. This here. All right. Perfect. I love it. Like what I see. All right. So I'm actually going to just keep, there it is. I'm actually going to do this one. Okay. Kind of like the output. Now it can be seen that the status of the port is not trunking, and this port functionality is up at trunk port. It can also be seen that the VLAN 10, right, the data VLAN and a 40 are now allowed on this particular interface. So what we can get into now is different port features configuration. So switches are layer 2 devices that can be smart and not smart, or managed and unmanaged, really. And unmanaged switches are good for small environments where you need a just connection to the network resources, and the host could be connected to a network in a plug and play kind of fashion. Managed switches are used in medium to enterprise level environments to provide, a lot of different useful features for a secure and efficient network, of course. So we want to get into speed and duplex, which are basic port parameters that are usually auto-negotiated on interfaces. Let's actually see where I can head here. Let's show interface fast internet /1. So that one is up. The protocol is up and connected, right? So that's fine. So that's mostly what I wanted to see. So I'm actually going to swivel over to SC001. Let's take a look at our control panel. Right? Okay. We actually want the new network status, right? And we want to change our adapter settings. And actually maximize this. So we're going to take a look at our properties here. Want to let's see, let's configure this. All right, let's take a look at our advanced and speed and duplex. There it is. Select it, I'll negotiate, and a value we need about, let's say 10 full. All right, that should be good. All right, now the interface is down for a moment, but that's fine, that's expected. Now I'm gonna reconnect to the switch here. I'm actually going to configure the terminal again. Okay. All right, perfect. So let's do, okay. Oh, okay. Can you let me, there we go. Finally, so now we can end it. All right, perfect. So now while configuring the parameters, the interface was fluctuating between down and up, which again is sort of expected. So now I'm just going to show faces again. Okay, now changing these parameters not have any impact, at least in this particular lab, but the steps are performed to show how these parameters can be changed. Having one port on the link that performs auto negotiation, the other port that does not auto negotiate can cause performance issues on the link, just FYI. So always ensure your ports are configured the same. Now let's take a look at flow control. Now, when there is congestion on the network, flow control configured on the Ethernet port enables us to avoid data loss, right? So it temporarily stops data transmission on the interface or Ethernet port, thus preventing frame dropping, right? For example, when you enable flow control on a switch port and if that port is experiencing congestion, it will send a pause frame to devices connected to that port, and the devices will then pause, sending frames, thus preventing frame dropping. Let's actually stop this and let's show some interfaces once more. Do that one there. Now it can be seen, at least from a quick glance from what I've seen here, that the input flow control is off and the output flow control is unsupported, which means that the flow control is only supported in the received direction. So let's actually mix this. And it's not how you spell configure. I'll get it right. Okay. And then let's take a look at our flow control. And Okay. All right, so now let me verify the interface settings. So let's, all right, perfect. So not too bad. All right, so let's actually take a look at what we were just looking at. So we take a look at those properties. One. All right, and let's configure. Let's do advanced, of course. Then take a look at its flow, and then take a look at the options available here. It's all right. Um, that's fine. Now, I'm not going to make any changes to the configuration settings. I just want to take a look, but we're going to actually get into, speaking of frames, jumbo frames. Now, most networks today, the maximum transmission unit is by default set to 1500 bytes, but in high-speed data center, speeds can exceed 10 gigabits per second, 4 gigabits per second, and sometimes more. Now, in some cases, if the MTU is set to 1500 bytes, it can cause problems with the network performance, since jumbo frames are used to provide optimal performance, right? So let's actually swivel over to this switch here. And we're gonna say no. We're gonna see a few more things, but we don't care. Come on. There we go. There we go. That's my guy. That's my guy. There we go. Okay. God, there it is. All right. And let's check out that MTU. Yeah. Oh, okay. All right. So let's take a look at our access. Now we're going to configure the jumbo frames with a few commands. I've just got to stop this here. And make sure we take care of that. So we have 1500 to 9000 MTU size of bytes. Now let's take a look at 9000 here. Okay, and that's fine. So let's exit out of here. All right, so now let's swivel over to SCO1. All right, well, we have our properties box still open. So I'm actually going to take a look at the jumbo packet, right? And 9014 should do it for me. And as you can see, it's down for a second. It'll be back up in a moment. And now we can get to port mirroring, which is also known as span or switched port analyzer on Cisco switches, which is another switch feature that can be configured. So I'm actually going to swivel back over here. So I'm actually going to configure terminal again. All right, we're going to monitor, if I can spell it correctly. Monitor session 1 source interface fast Ethernet 023, right? And then now I'm going to configure the span destination port with a few commands. So I monitored session 1, but actually I'm going to do something a bit different. gonna do the destination, like I said. Okay. Perfect. Okay, like that here. All right. And now to take a look at our changes, I'm actually going to have it show monitor session one. Right. Native disabled. All right, perfect. So that's fine. That's what I want to see. Now we can take a look at port security, which is a kind of MAC filtering security feature that we can configure on switches. Now, when you enable this on a switch port, you're actually limiting the number of MAC addresses on that port and enabling MAC address filtering. In practice, I configure port security on all user-based ports and not on ports connected to other switches. Now, when port security is enabled on a port, users cannot change their PC and connect another device to that port. If they do, the port would be locked because it would be technically a port security violation. So what I'm going to do is configure port security for core 2 and a switch in the access port where the IP phone is connected, and then the trunk port facing access 1, and then take a look at the results. So let's start with core 2 first. And perfect. So let's take a look at in here running configurations. Okay. Do that first. All right. And then now we can do what we want. All right, building 137 bytes, switchboard VLAN 10, 40 for the phone. All right, now I'm going to configure the port security for this interface, or on this interface rather, by issuing the few commands. So let's get into the terminal. Of course. All right. Okay, now turn on security. Okay. Now I'm going to review other port security configuration options too. I do this here. Aging, MAC address violation, blah, blah, blah. So I'm just going to end that. Now you do have an option to specify maximum secure addresses on this port. For example, or I would normally have an option to specify. Now, for example, if I have a computer connected to this IP phone, then I would specify the maximum value is 2. Now I can have a default of 1 MAC address, and I would also manually specify that MAC address, specify the MAC address that is allowed on this interface. So now I can have it show me some port security again. One MAC addresses limit 6144. Okay, not bad. So let's get back into the terminal. All right. Oh, okay. This is fine. This is fine. This is fine. Now I just wanted to wait a few seconds to third the output, but looks like I really don't see anything. But I was expecting that since this is a trunk port, that I should have several source MAC addresses on this port. Port security should show violated, and that is in a down state. But nonetheless, I'm gonna end it here. Then I'm gonna shuffle the security again. No violation still. Oh, okay. All right. Nonetheless, since this is a trunk port, the port security should not be configured here. I'm not going to remove it and verify that the interface is in an up state again. So let's figure this once more. All right. All right. There. All right. So we're good here. So let's look at some more interfaces. Perfect. So like see now from the output, um, we can surmise that the interface is in the error disabled state caused by the port security or the supposed it should have been a port security violation. And after port security violation, you normally need to issue a shutdown and no shutdown commands on the interface even after the port security configuration. So I'm just going to stop this and get back into the terminal one last time. And then interface. Fast, do that, do that, and I want to do a shutdown. All right. Now it's up, but we're gonna end it. Now there's a now I'm going to take a look at MAC address table in ARP. And a MAC address, what it does is at least a table, it maps the MAC address to an interface on the switch. And using a MAC address table, the switch would know where to send a frame since the destination MAC address is specified in the table. So what I'm going to do now is actually have it show me the MAC address table. Perfect. I like to see. Now from the output, it can be seen that the first 20 entries are all VLAN that have local MAC addresses, right? That belong to the switch, and other entries are MAC addresses that usually belong to other devices. Let me take a look at one in particular. Looks like I can't see it, but nonetheless, I'll swivel over here and take a look at our command prompt. So I can see everything here. Now from the output here, right? The MAC address from the switch MAC address table is mapped to interface fast Ethernet 0/1, where this particular server is connected. The MAC address table is dynamically populated, but static entry and other parameters can also be configured. Now, the question mark is used to view all configuration options and like issue a few commands. So I'm actually going to swivel back over here and go back to the terminal. Again, but I need it, but I do. It's actually all right. So we see the output, right? Now I'm going to create a static entry by issuing another command here. Oops, not what I wanted. UNC. Now let's see here. Some extra sauce under my command that I didn't know about. Still didn't do it right. Let me fix. Well, it looks like it was, but it wasn't. This table. VLAN and okay. All right, I guess that's fine. All right, exit now. Let's see it. All right, so now we see the output, the aging time should be shown. Now, this is not a real MAC address. This is used to see how static entries can be configured on the MAC address table, by the way. Now, the aging time can also be configured on the MAC address table. So I'm actually going to view the default setting for this. Let's do all right, so I see that output. It can be seen that aging time is set to 300 seconds to probably, I would say, about 5 minutes. So I'm going to change the default setting of the aging time by doing a few commands here. How do you spell aging? Just have to spell it over just because. Let's see. I see what happened there. Usually user error. There we go. Got what we wanted. Aging time. Okay. We can exit here. Right now we can show the address resolution protocol. Okay. There we go. Okay. So it only has, okay, a couple entries, but mainly one entry in the table. I'm going to issue a ping out to a few different IPs. Okay. Okay, no problem. Okay. Okay, no problem. So let's view it again. Yeah. Huh. Another one is here. How you doing, buddy? I got 3 entries. Now these are populated dynamically when a packet is forwarded to a device. Now, what I want to do is take a look at spanning tree protocol and port aggregation. Now, STP is enabled by default on most switches and it keeps the network free from bridging loops while having redundancy between switches. And that redundancy can be implemented by having two physical connections between two switches or having three or more switches that are interconnected. What I'm going to do is going to have a spanning tree that's going to run in this topology since I have a redundant connection between core one and core two of those particular switches. Let's swivel on over here. Let's stop this going. We're going to show running configuration, include setting. Okay, all right, not bad. All right, so let's show. Um, actually, no, CT start acting up. All right, that's what I wanted. So we can see all of this in its glory, right? So it can be seen that core two is not a root bridge for VLAN one, right? So, and that's fine. Now we can actually take a look at the STP for VLAN 10. Yeah, size. And I make one mistake. All right, so now I can see here, right, that FA1022 is participated because VLANs are not configured on core one. That's why. So I'm going to configure the VLANs and other settings on core one by issuing a few commands here. So let's do. Yeah, let's do that. No, we do not. Configure terminal, of course. VLAN 10 name users. VLAN 20. Of course, it's going to be servers. Huh? Mm. Oh, show. Yeah, my CTE active. All right, let's take a look at that IP. So now I'm going to create a trunk on ports core one and core two. And now from the lab topology, we can see, or I can see that these are fast Ethernet 1023 and fast Ethernet 1024 ports. So let's start with core one since I'm already here. Okay. See what happened there. There we go. Now I can do it properly. There we go. Okay. All right, perfect. So we can actually end it. And now I can do the same to core 2. All right, and let's do switch ports. Okay, and we can actually end it. All right, so now we're going to check I'm going to check the spanning tree instance for VLAN 10 on the switch here. So that's because I put in the wrong thing. There we go. How you doing there, buddy? All right, perfect. Now the trunk ports to core 1, right, are now shown as root and whatever this is, alt n, which means that one port is in a forwarding state and the other is in a block state. Hence, STPF provided the loop-free environment. So let's swivel over to core 1. We're going to have it show us the spanning tree, what it looks like from this end. All right, so what we can see here is that in core New York and Y core, one is a root bridge for VLAN 10 and both ports are in a designated and forwarding state. Now, I'll see what happens if the fast Ethernet 1023 port changes the state to down. I'm going to swivel back over to core 2 and I'm going to first enable debugging for spanning tree and then administratively shut down interface fast Ethernet. So let's do this here. All right, perfect. So now we can shut it down. Okay, perfect. So it's shutting down slowly but surely. Now, also what it's doing, it's going through a listening state, and then after usually about 15 seconds, it goes into a learning state, and then after that, it goes into a forwarding state. So it takes at least 30 to 45 seconds to have a new path up and running in the environment. This is one of the biggest drawbacks, unfortunately, of STP, slow convergence. And I'm actually going, here we see the learning here. Um, and then after this is finished with the forwarding state, I'm going to see how the rapid PBST works. Because I'm going to first bring the FA1 up again on this switch and then disable the debug. Um, so I'll do it once this is finished up here. All right, so let's exit out of here. Right. And now we're going to take a look at our interface fast internet 1023. Right. like I said, I'm gonna undebug it. Come on, let me work here. All right, perfect. So now I'm going to enable the rapid PBST mode on both the core one and the core two. So actually swivel over here. I'm going to exit out of here. Then I'm going to swivel over to core two, do the same. All right, perfect. So now I'm going to take a look at the STP instance for VLAN 10 on both core one and core two. So for core two, let's start here. Okay. All right, so now let's do core one. Actually, I don't. Okay. All right, so now I'm going to check redundancy and failover. So I'm actually going to swivel back over here, enable debugging, and then shut down by issuing a few commands here as well. So let's debug spanning tree. That's, and I'm going to configure the terminal. And all right, perfect. Now, I'm not sure if you caught that, but it immediately went from goes into a forwarding state without going through the listening and learning state. Now I'm going to disable debug on this device. Um, let's see. Let me. All right, perfect. So I'm going to go back to core one. We're going to configure the terminal there. All right, interface range. Got to shut down. Group two. Okay, perfect. But I want it. So with the question mark, it was just used to check all the options for creating a per channel. Now, dynamic protocols like LACP and PHEP can also be used for creating port channels, or an on configuration option can be used to manually enable link aggregation. Now, for the task I'm doing, the LACP protocol was used since it is a standard protocol. PHEP is a Cisco specific protocol. So I'm going to redirect back to core two. And I'm actually going to see what state am I in. Right. Then going back in here. Okay, now we can actually shut this down too. And the channel grouping. Got it. Okay. All right, perfect. Now just redirect back to core one. Now shut down. All right, perfect. And core two. No shutdown. And all right. Now I'm going to connect to core two. Starting. Let's not get crazy here. But I was finally able to get it, and this is what it shows, right? As far as our output. So I'm going to connect right back here. Same, man, without any distractions. Perfect. So from the output, we can see, or I can see that STP now sees these two interfaces as one port channel interface, and I still have a redundant path in the environment. If I look at the lab topology, I'll see that I have a redundant path between access one, core one, and core two. So now, lastly, we can take a look at the link layer protocol. Now, two link layer protocols used to advertise device capabilities and details are LLDP and link layer discovery protocol and CDP or Cisco discovery protocol. So I'm actually going to swivel over to core two because what I'm going to do now is examine the CDP protocol that's enabled by default on the Cisco device. And I'm going to also configure the LLDP to see how it works. So let's ask it to show us the CDP, right? And we see a few things, the global, the CDP package, the whole time value, things of that nature. You can also show CDP neighbors. Howdy ho neighbors. Here we go. No, that's from here. There we go. Now, the neighbors, of course, are the other switches that we have here in the server. And the switch on the phone will exchange information about voice VLAN and data VLAN configured on a connected port. Data that's normally exchanged in CDP advertisements contain information about the platform, the software version, the host name, IP address, and interface, and some data just may not be shown using this command, unfortunately, but I will need to use the detailed keyword. So let's actually do another. Let's see the details. See all this wonderful stuff. Right. Now, CDP is enabled by default globally again on Cisco switches. Now, to disable it on a particular interface, we can actually do a few things. And I'm going to show you one of the ways of those few things. Pick a terminal. Okay, there we go. Then we can end it. Perfect. Now I can view the CDP neighbors by issuing a few commands a few times until the IP phone disappears from the list. So I'll take a look. I'll take a mental note of the whole timers as well. So let's do Okay. All right, not too bad. Now let's take a look at our core one. ODP, run, then exit, fine. Then I go back here and configure terminal again, exit. All right. All right, so now I'm going to display the LLDP neighbors. So I'm actually going to swivel back here. Okay, not too bad here. I actually can do the same thing here as well. So now we can actually take a look also at power over Ethernet or PoE, which is a switch feature that can give power to connected devices by passing electric power along with data over Ethernet. So to display this, I'm actually going to have it show power in line. And we'll see it just pretty much just continues going and going. Now on the port fast Ethernet, you notice the IP phone is powered from the switch and it uses about 6.3 watts from a maximum of 15.4. Right. So I wanted to point that out and we can actually go back to the terminal. Okay. And power in line. It shows us the details for that. And the PoE can also be disabled on the port as well. But nonetheless, this brings us to the end of a long one, but a fun one. Overall, what we did just a few things. We configured some VLANs, access ports, and trunk ports, and then we also went over some port feature configurations. Again, this was fun. The next one's going to be even more fun, where we go over routing concepts and protocols. Hope to see you there. Stay curious, stay secure.